looking to compare three different fire dampers. This one here tested to UL555 and UL555S. This is actually a 3-hour listed smoke and fire damper listed by Underwriters Laboratories. This is a motorized damper as well. This one over here is a German damper. It's tested to DIN4102 and recently the EN15650. Also a mechanical damper. This is a 90-minute rated damper. Both smoke and fire. You can't have one without the other. They do both necessarily. And over here, intumescent dampers. A little simpler. Made by these guys, ZZ. Zimmermann in Cologne, Germany. The UL555 rated damper, when you buy it, it comes in 3 parts. There are 2 angle lips that go on the duct. Both of the 2 mechanical dampers, this one and that one, were made to accept a 1 foot by 1 foot duct coming into either side. This one here has the angle flanges separate and apart, whereas the German damper has it integral. Also, this here is made of 22 gauge sheet metal, which is like 0.8 millimeter. This actually clocked in at 0.88, a little bit over 22 gauge, a bit of a bust tolerance. This one here clocked in at 18 gauge, over 1.3 millimeters thick. So the idea is that this damper goes inside, like any damper goes inside of the sheet metal ductwork. I'll show you. This is an example of sheet metal ductwork. The idea is that if a duct traverses a fire resistance rated assembly, like a wall or a floor, it doesn't matter. Let's say there were a 2-hour fire resistance rated wall all around this. Okay, this would be 2 hours worth in fire resistance, and sheet metal ductwork like 22 gauge, that doesn't really provide any fire resistance rating on its own. It would need some help in order to be able to pass a fire test. So the idea is that where the duct traverses a fire resistance rated assembly, wall or floor, the damper goes inside of the duct, so that if a fire comes, the blades shut, so that the integrity of the fire barrier is maintained. That's the purpose of the fire dampers. Code-wise, they're called closures, same as fire resistance or fire protection rated windows or doors. Those are all closures in accordance with the code. They're also through penetration fire stops. In Canada, they look at those rating-wise as closures. They can be D-rated, same as dampers and doors. If I had a 4-hour wall, I'd need a 3-hour fire damper, or 3-hour window, or 3-hour door. Having said that, there are significant differences in testing. A number of years ago, all fire doors switched from being tested under negative furnace pressure to positive furnace pressure, which makes a lot more sense. We do a little thought experiment here for a minute. Let's say that this Tupperware box were a fire resistance rated compartment. A compartment could be one room, or it could be a number of rooms, right? Let's say, hyperallergenically speaking, we throw in some fuel, we put a lid on it, and let's say this were a fire compartment inside of a building along with others. If fire starts inside of such a compartment, and the compartment is in fact engaged, the idea behind passive fire protection is, in general, that the fire and smoke not escape, that it's actually maintained, contained within its own boundaries, right? And fire dampers are to ensure that boundary where ducting has to traverse. Now, one thing that happens when a fire starts in a fire compartment, heat rises, everybody knows, which means that you would have a higher pressure at the top, lower pressure at the bottom. Like if you had unprotected openings at the bottom with a lower pressure, it would then suck in fresh air to fuel this thing and make it worse. If you had openings at the top above the neutral plane of pressure, so if you do have a fire, being that heat rises, you're going to establish a neutral plane of pressure with lower pressure below and higher pressure above. So if you had an opening here or here, right, then the higher pressure there would send superheated, reignitable fumes and smoke and so forth out through those openings to then spread outside of the compartment, which would negate the purpose of the compartment. The idea behind the compartment is to keep it there so that the fire can be contained and put out, people rescued, and egress and so forth. So when I'm saying that UL555 test series mandates testing under negative pressure, right? Unlike fire doors, which were switched from negative to positive, what that means is that this is perfectly functional and applicable to reality in cases where this is located below the neutral plane of pressure, because then on the fire side you've got negative pressure. But that's difficult to guarantee in reality, right? I mean, the door may open, there may be a flashover. Where exactly that neutral plane of pressure is going to be is difficult to predict under all circumstances. And erring on the side of caution, we've gone to positive pressure. E119 walls, or ISO 834 walls, DIN4102 walls, and so forth. All the walls and floors are all tested under positive pressure. So doors were switched to that, but dampers have not yet. Right? And I don't know that there's any movement to switch this, but it has some significant effects. One of the effects being that the test standard calls for fire testing under negative pressure, right? It makes sense that that influences the design choices, how this thing is built and made, right? So if I turn this around, when you look at this, and again, this is a motorized damper. If you look at the damper blades there, and I haven't hooked this up to electrical, so I'm just going to turn this manually. Here it's open, and here it is closed. Now you can tell that this isn't particularly thick, right? And when the negative pressure with fire is on in a fire test, what happens is normal physics, that if let's say this were the slab being fire tested and there's a damper sitting in that test floor and it's under negative pressure, what's going to happen is that you've got positive pressure in the test lab on the outside, negative pressure in the furnace where the fire is happening and the heat is coming from. Then what's going to happen is that cold lab air is going to rush through any crevices, both on the inside and on the outside of this, if there were any openings, and this rush of cool air will cool this thing down, right? So, and in that regard, I'm mentioning this is 22 gauge. This thing here tested under positive pressure, 18 gauge, like over 1.3 millimeters thick. Now, there's an organization by the name of SMACNA. You can look them up on smacna.org, and they put out a document called Improper Fire Damper Installation, right? Better to do it right than wrong. And the one thing that this focuses on is the gap around the outside of the damper. If you're looking at this at the distributors, it looks nice and integral. Where would there be any leakage, right? And it's tested for smoke resistance as well as fire, so one does not get the impression that there's a problem. But the idea is that this lip goes around this, and the purpose of this lip here on each side, the purpose of this lip, right, which gets fastened through these holes into this sheet metal, the idea behind this is that the damper be held in place, right? right? Because they have such a thing as they call a drop test under UL555. If we take our gravity still works. If we take our mock fire resistive wall, if there were a damper inside here and a duct going through, the idea behind the drop test, which is not done during fire testing, it's done totally separately, typically at the manufacturer's place from what I gather. So duct goes through, damper is inside the fire resistance rated wall assembly, and a weight is dropped onto the ductwork, and the attachment between the duct and this damper assembly is made purposely in such a way that if a weight were dropped on there, that this would let go, so that if there were a force pulling on this duct, that it would not dislodge the damper from the wall assembly, right? Now further, SMACNA indicates in this document, and it's backed up actually by 2 letters from manufacturers. These are I just printed this out from smacna.org, but there's a letter here from Air Balance Inc., Mr. Lichtenwald, Roger A. Lichtenwald, and then another one from a company, Ruskin, a fellow by the name of Robert Van. I'm not going to try and pronounce that last name. Anyway, both Robert and Roger, both of them indicate the necessity, which is true, that there needs to be at least a 1/4 inch gap all the way around this. And the actual gap, the minimum gap, the tolerance is minimum maximum with regards to the gap between the outside of the damper assembly and the inside, the opening going through the fire resistance rated wall or floor assembly, is dictated by the listing, the certification listing that follows after successful fire testing. So here's what this means when you think about it. This is a 3-hour rated fire and smoke damper, both 3 hours fire and smoke. But while they're addressing the smoke on the inside with some lips, maybe you can focus in on this. You see there's a bit of a rubber lip here, and there's a bit of a rubber lip there. Not there. Here's one as well. So while that's there to counteract smoke, but by virtue of the fact that the outside of the damper, whether it's got a smoke rating UL555S or not, the outside needs to be without a fire stop, without any caulking. And the reason why they make a big deal out of this is because in the 1980s there was an enterprising individual from Calgary, Alberta, who figured out a way to increase his fire stop contracting business. He discovered that there was this gap that goes around the outside through which this damper breathes and cools down during the fire test, right? So he decided, okay, he was going to persuade consultants, architects, engineers, that part of the fire stop spec, which is now under National Master Format 07840, used to be 7270, now it's 07840 was the latest one. So fire stop contractor would have to go along, or somebody would have to go along and then put a bead of caulking here and here all the way around, right? So this wound up in the National Master Spec of Canada. It wound up in specs all over the place. There are buildings all over North America where people have gone along and put fire stop caulking around this angle lip. And every time that they did this, right, they invalidated the certification listing for that ductwork, because it has to be able to shed heat. It needs to be in a negative pressure environment according to the test procedure, and suck cold air past it in order for it to survive. Now, having said that, when you think about it, what about, back to our thought experiment, fire resistance rated compartment all the way around, 6 sides with a 2-hour rating, let's say. If you have a damper at the top, and let's face it, ductwork is typically at the top, right, where you've got positive pressure. So If this only works below, or it's only, I'm not saying only works, but if it's only tested to work below the neutral plane of pressure, then what's going to happen when it's at the top? Well, this hasn't been fire tested that I know of, but because of the fact that you're not allowed, according to SMACNA and the manufacturers that build these that have successfully been tested and classified to UL555 and 555S, if you can't button up around the outside, that means you've got a gap. And this thing needs the gap in order to survive this particular test. And what that means is that if such a damper is above the neutral plane of pressure, then what's stopping these superheated gases and smoke to be pressed around the outside of such ductwork if the duct and the damper are located above the neutral plane of pressure? So that's sort of the testing background behind that. Now let's take a look at the German one. So this particular one, you can see, made by Trox Technik, tested to DIN4102, and then after the European deal happened, EN15650. So it's a 90-minute rated damper. Even though, as for a 1 foot by 1 foot duct, actually 30 by 30 centimeters, close enough. This damper is actually a little bit heavier than its American cousin that has twice the rating. The American one we just looked at, to UL555, is less heavy, and it's got a motor on it. This is not a motorized damper. So let's take a look at how this works. Okay, instead of multiple blades, this has one blade. And this here is identified, it's an identified passive fire protection board. It's Promatect H, which has been around for a long time. Now, I'm going to show how this works. I'm pulling this out, right? And you can see here, it's on a pivot. It has a door stop. It's stopped here and it's stopped there. Here's your fusible link. This thing here will melt, right? So when this is in the open position, I'm just going to move this here. When this is in the open position, which is normal operation, right? If heat comes, this sucker melts. It'll pound this rod through, come to the other side, which then knocks this out. And as soon as this gets knocked out, boom, it's shut. Okay. Now you've only got the one blade, and you've got a thick blade. This is Promatect H, 40 millimeters, okay, with a gasket and a counter gasket, and that's how that operates. Now, having said that, let's take a look on the outside for something significant. This is the location of the damper blade, the Promatect H board. Okay, this is one side of the pivot, right? And this doesn't move or anything. It doesn't do that on the other side either. Let's just take a look at the reverse. There it is, and you notice that it's punched, so as to have a tight fit between gaskets and board, because it has to defeat smoke as well as fire and heat. So the idea here with the German damper is that there is no exterior gap required. Why would you not want an exterior gap? Because you wouldn't want to depend on this assembly being necessarily under positive or negative pressure in a real fire, because you don't know that going in. It could go either way. Chances are, because most of the ductwork runs at the top of the room, chances are it's going to be under positive pressure. So no matter whether it's positive or negative, the Germans don't want any smoke migration around the outside. So what they've done is they've indented this and then a fire stop mortar is installed here, which then also will draw heat away from this assembly, and it won't let any smoke through, right? So, and that's how that operates. Now let's take a look at a simpler one. So that one's hooks. Look at it a little bit simpler now. Like this here is these are intumescent dampers. They're not the same size. These are just samples that I had lying around. And what happens is that under fire, this expands and it swells shut. So positive pressure, negative pressure makes no difference really. If this is under heat, it'll swell and it'll compress these openings shut positively. I've personally fire tested this material a number of times over many years. It's never failed me. It comes in different forms, half shells for around piping, backer rod, gasketing. You can get it in a foam in a cartridge, and you can dispense it. It mixes A and B together and it expands inside the hole. Most importantly, it comes in different densities, and this would be a high density, obviously, and because then there's more graphite, acid wash graphite, in order to press this whole thing shut. So, so yeah, this is a little simpler. This is not the standards aren't allowing for this right now in North America, but technically it's definitely a solution. So downsides. Now, intumescents rely on hydrates typically in order to function. Hydrates tend to dissipate over time. In order to counteract that, the hydrates here are bound inside of a covalent matrix, and this is actually DIBT approved, which makes it necessary to have aging backup through the DIBT test procedure, which is second to none in the world. So they actually have some, and they have backup beyond that, but I only have that secondhand. There are DIBT approvals on this material right now as we speak. And it's used in penetration fire stopping as well as in damper assemblies. And this is the outfit Z-Z.de. I'm pointing this one out here because most HVAC folks would know these guys, but they may never have heard of this. And somebody needs to take the bull by the horn to get this tested and get it so you can use it per code. Now, back to the mechanical dampers. Let's just do a little light test, right? I mean, if you can see light through, smoke can travel through that. So I'm just going to show this is just a normal LED construction light from Home Depot. So let's do the American damper first. Okay. Right. By the way, just for station identification, I loosened this so I can turn this by hand. So right now it's shut. I'm gonna open it. You can see the light, literally, and now it's totally shut. Now you can see light coming through some of these crevices down here, there, all the way around. I mean, that's just straight light going through, right? And this is under ambient conditions. We'll lift the American one aside. Take the German one. Okay. Open. Position the light a little better. Okay. Open. Shut. So with this one here, you can see it's at the pivot points where it's got to move. That's typically where you see the light. But it's only got the one blade, so it's not, it's easier to keep that one tight.